On to section 1.3, where we're going to talk about frequency, frequency tables, and levels of measurement, and not in that order, because that's not the order they're presented in the textbook. There is some advice at the beginning of the chapter about rounding. It talks about how it's usually fine to leave things as fractions in this course, and sometimes it's actually better to leave them as fractions. But if you are doing any calculations for homework, you can use the advice that they give here. And if you run into any issues with rounding, let me know and we can figure those out together. So, levels of measurement. This is the way that data is measured. So a set of data is measured. And it's very related to the type of data that you are measuring, and it ends up making quite a bit of sense in some places and being really bizarrely difficult to explain in others. So I'll walk through this a little slowly. There's not a whole lot more in this section, so I want to make sure that we really understand these levels of measurement, because the types of statistical things you can do, the types of ways to measure data, depend on the scale that's being used to measure them. And so some data you just can't do certain things to. And it kind of makes sense. Like, you can definitely do different things with colors than you can with numbers, and you can do different things with satisfaction scales than you can do with weights. There's all sorts of ways to look at things, but the processes that we learn to analyze things later on can very specifically apply to only certain types of data. And so we've got a nominal scale, we have an ordinal scale, we have an interval scale, and we have a ratio scale. So data that is measured using a nominal scale is qualitative data. And the trick in remembering that this goes with used to measure, let me say that first, measure qualitative data. From before, we talked about qualitative being qualities of things, categories of things. Nominal, the root word in this, it's talking about names, not numbers. So the name of a category. And so when I see nominal, I think of something that has a name and not a number. And that helps me to remember that we're talking about qualitative things. So nominal scales, they're not in any kind of order at all. So categories, it doesn't make sense to put in order. Used to measure qualitative data that does not naturally fit into an ordered list. And so red, blue, yellow, we've talked about colors a lot. Those, it's not red is more than blue, or there's no order to them. It's just a category. If I wanted to see how many people had different first names at VTSU, the names don't fit in any priority order. That's not a thing. So if it's just the name of a characteristic, the hair color, that's nominal. It's not something, it doesn't make sense to say that brunette should be listed before blonde should be listed before black hair. That doesn't make sense. So when we're talking about a nominal scale, it's categories, qualities that don't have a natural order to them. Now, an ordinal scale is one that measures qualitative data, but it does it in a way that it is in order. So ordinal scale, qualitative data that needs to be ordered. And so that would be things like freshman, sophomore, junior, senior. There is an order there. If we were keeping track of medals at the Olympics, bronze, silver, gold, there is an order there. Anytime you have categories, but there is an order implied in the categories, or the 0 to 5 scale of how satisfied you are. Satisfaction, that Likert scale we talked about in the last video. How satisfied you are, we can put that in order from not satisfied to fully satisfied. It wouldn't make sense to mix up those rankings. So we use the ordinal scale for qualitative data that can be ordered but can't be measured in any meaningful way. The next one is the interval scale. The interval scale is something that uses data that can be measured. So this is quantitative now. Intervals are quantitative. And there are very few examples of data that is appropriate for an interval scale. But one of them is temperature. Another of them is the, let's say, calendar years. I'm going to write those two things down in the notes, and I'm going to come back to them because explaining what an interval scale is harder than explaining what a ratio scale isn't. So let's see what ratio scale measures first. Ratio scale is also quantitative. So it looks at numbers that can be measured. Quantitative, and for something to be a ratio scale, and almost everything is, 0 means literally nothing. So if I am measuring speed and I say I'm going 0 miles per hour, that is the absence of speed. If I'm measuring height and something is 0 inches tall, that's the absence of height. If I am measuring weight and something weighs 0 pounds, that's the absence of weight. 0 means there's nothing there. So that's an important part about something being a ratio. And that's different if we look at temperature. 0 degrees does not mean an absence of temperature, right? It's just, it's a number on a scale, but it doesn't mean that there's no temperature. Absence of temperature. The year 0 doesn't mean no time has passed. I'm actually going to get rid of the calendar years explanation because it's not going to come up. Let's just stick with temperature for a while. So when we're looking at temperature, not only does 0 not mean the absence of temperature, because it can definitely get colder than 0, but like 0 degrees Celsius means something different than 0 degrees Fahrenheit. So like 0 isn't even consistently applied. 0 pounds is 0 kilograms, is 0 ounces, is 0 anything you use to measure weight. 0 miles per hour is the same as 0 kilometers per hour is the same as 0 feet per minute. Any way you measure speed, 0 means the same thing. That's not the case for temperature. Any way you measure temperature, 0 could mean something very, very different. And no ways that we measure temperature does 0 mean there is no temperature. That just doesn't make sense. And ratio scale, like the word ratio actually is important. You can make meaningful ratios, with this data. And so what that means is 10 miles per hour is twice as fast as 5 miles per hour, right? 10 over 5 is a ratio that equals 2. Like, that's a ratio that means something. And we could do the same thing with weight. You can have a ratio where something weighs 1/3 of something else. And no matter how you measure the weight, it's always going to be 1/3 of that other thing. I don't know why all of this stuff is popping up on the screen right now, but so be it. So ratios can be constructed from the data if you're using a ratio scale. You can't do the same thing with temperature. So it doesn't make sense. It doesn't make sense to say 30 degrees Fahrenheit is twice as hot as 15 degrees Fahrenheit. Like 30 over 15 doesn't mean anything. And especially when you start looking at negative numbers, like, this just doesn't make sense. So what does this ratio mean? Negative 10 degrees to positive 10 degrees. So that ratio is a -1. It's -1 times as cold. Like, it doesn't make sense to talk about ratios when we're using temperature. And so we can't make the same types of comparisons with interval scale that we can with ratio scale. The interval scale still has like the same distance between every degree Fahrenheit, or the same distance between every degree Celsius. It's like internally consistent, but 0 doesn't mean nothing, and we can't make ratios. And so that's what it means to be an interval scale. So essentially, if you see examples that use temperature, those examples are going to be interval scale examples. If you see quantitative data, measurable data that is not temperature, there's a 99.99999% chance that it is ratio scale. But just ask yourself, does it make sense to say something is twice as fast as something else? Yes. Does it make sense to say something is twice as cold as something else? No, it does not make sense to say that. So those are the scales. So I ask here for you in a reflection to try and make a diagram to classify the levels of measurement, because we've got a lot of stuff and it can be hard to determine what fits into what categories. So I start with the way that I like to think about it, and you can choose to think about it a different way. I'm going to put my qualitative data over here. I'm going to put my quantitative data over here. Oops, quantitative data over here. And if we go back to the words that they used, nominal goes with qualitative, and ordinal goes with qualitative. So qualitative data, nominal is a kind of qualitative data, and ordinal is a kind of qualitative data. Quantitative, we have interval and we have ratio. And really, technically, these fall under the category of, types of data. So you can see how those fit into things. And then there's also kind of this idea that we talked about last time about interval and discrete. And we can have, or not intervals and discrete and continuous. We could have continuous intervals and ratios, and we could have discrete intervals and ratios as well. And so if we wanted to look at quantitative data, we could say that some of it's continuous, some of it is discrete. And in both cases, you could be measuring things in ways that only go in specific increments. So that would be interval, or things that, discrete. And we could measure things in ways that have fractions and decimals, and that would be continuous. So I think about it that way. You can choose to think about it however you want to think about it. It is entirely up to you. Okay, onward. Frequency. This is the last bit of this section. Frequency is it's the number of times a value shows up in a data set. So the number of times a value shows up in a data set. And if you look at table 10.1 in the book here, 1.10, I can read that table 1.10. There you give us a list of responses: 5, 6, 3, 2, or 3, 3, 2, 4, 7, 5, 2, 3, 5, all of those responses. So the table here lists the data values, all of the values that show up in that list, 2, 3, 4, 5, 6, and 7, and then it lists how many times each value shows up in that list. So the frequency of 2 in this data set, you just go through and look, how many 2s are there? There's 1, there's 2, there's 3. That's all of the 2s. 2 show up with a frequency of 3. You do the same thing for every number in there. That's the frequency. It really is that straightforward. How often does a data value occur in a data set? Relative frequency, instead of giving it a word definition, it is the frequency of an object or a value in a data set over the total number of things being measured. So if we had, in the case of this data set, if you've got it set up so that you have the data value and the frequency, the relative frequency, you need to figure out how many pieces of data there was, that total pieces of data. That's 3 plus 5 plus 3 plus 6 plus 2 plus 1, which is 20. Or you could go back and count how many numbers there were in the list. 1, 2, 3, 4, there's 20 of them there. But your frequency, or your relative frequency, is going to be the frequency divided by the total. And you can leave those as fractions if you want to leave that. See table 10.11 again. I did it again. See table 1.11. You can see that it's the frequency of the object over the total number of data points in your sample. Then we have cumulative relative frequency. This is the relative frequency plus all relative frequencies for lower values in, or actually we'll say it higher because it's the way it shows up in the table. Hang on a second. Higher values in the table. So this is easiest. It's a little bit confusing to write. It's a little bit confusing to define, but it's easiest to see when we look at how to do it. And I'm going to have an example of a table that we can fill out so we can practice with it. So in this case, we've got the data value, the frequency, and the relative frequency from before. And the relative frequency for all of these, again, is just the frequency divided by the total. So it's this number divided by 20, this number divided by 20, this number divided by 20. Relative frequency, then we can turn into a cumulative relative frequency by starting with the first thing in the list. So we are saying that 15% of the data values were 2 or below, right? That's the lowest value that we've got. So you're literally in that first cumulative relative frequency, you're going to copy exactly what was in the relative frequency value. When you move on to the next one, you're going to do the one before it plus the one it is and get a total. So in this case, you're looking at this as this plus this equals that. This plus this equals that. This plus this equals that. It's kind of this diagonal action. And again, that's easier to see the pattern than it is to define it. So let's do that here. We've got a table in the practice notes that I want to fill in so that we get a chance to practice with this. So the frequencies, I'm going to pull up let's do a web-based calculator. Let's just do Google Calculator. That'll be enough for what we need here. So again, relative frequency is the frequency over the total. So in this case, it is 320 over 800. And I'll go ahead and just do 320 divided by 800, and that'll turn it into a decimal for me. That's 0.4. 240 over 800. And so let's do some arrows here. The number, I'm trying to do some arrows here. The number will go on top in the fraction, and the total will go in the bottom. I'll do that with a highlighter. Oops, total's going to go in the, that's too thick. Let's go with this. So total in the bottom, total in the bottom. And I can even like pre-highlight this. It really fills the pattern so simply that I know exactly what's going where. I don't even have to think about it. So 120 over 800, 80 over 800, 40 over 800, and the total, it's 800 over 800. And we can do the calculations now. So 240 divided by 800 is, oops, not plus anything, back. 0.3, oops, color, 0.3, 120 over 800, 120 divided by 800 is 0.15. Some of you may be comfortable doing these calculations in your head. It's okay if you are. Go ahead, knock yourselves out. If you're not, use a calculator for this. Use the cell phone calculator. Use Google Calculator. It's okay. You don't have to feel like you have to be able to do any sort of computations in your head for this course. 800 or 80 divided by 800. 80 divided by 800 is 0.1. 40 divided by 800. 40 divided by 800, not minus 800. That will not give me the answer I'm looking for. Divided by 800 is 0.05, and 800 divided by 800, that's 1. That's 100%, which is good because that's the total, and the total should be 100%. So cumulative relative frequency. The way this works again is you are going to copy this directly, 0.4. And then you are going to do this plus that will equal this. 0.4 plus 0.3 is 0.7. This plus this equals this. 0.7 plus 0.15 is 0.85. This plus this equals this. 0.85 plus 0.1 is 0.95. And then this plus this, oops, wrong color. This plus this is 1.0. So that gives us the way to calculate the relative frequency and the cumulative relative frequency. And now let's figure out how to interpret those things by answering the rest of the questions here. I'm going to make this bigger in the notes here. So if you want to find the percentage of students who, this is students visiting getting mental health resources, the number of times per semester that they did this. So I'm going to use some highlighting here. So students who visited fewer than 6 times. So I could look at these and add those up and divide by the total, and that would give me the information, but it's already baked into the chart. I could look at this and add those together, this one here and this one here, and add them together, and that would also tell me the percentage of students who visited fewer than 6 times, so between 0 and 5 times. But that is what the relative frequency tells us. So all I have to do is look at the relative frequency that comes before 0.6. My highlighter back again. This right here is the visited fewer than 6 times. It is 0.7. Find the percentage of students who visited between 3 and 11 times. So let me go back here and make a note. Where do I want to write this? This tells you percentage fewer than a value. That's what that tells you. If I want to find the percentage of students who visited between 3 and 11 times. This one I'm going to go to the relative frequency. So these students visited, these students visited, these students visited. That's all of the students that visited between 3 and 11. So that's going to be, let me get the highlighter there so we know where I found that information. 0.3 plus 0.15 plus 0.1, and that's going to give us 0.55. You could do that other ways. There are other ways to get that same value in the chart. Well, let me make sure I did that right. 3, 4, 5, 5. Yep, 0.55. You could. I'll show you. You don't have to do this. If this makes sense to you, don't pay attention to what I'm saying now. If you want another way to think about it, we could go to the cumulative frequency, and the people who visited between 3 and 11 times, I could look at this 0.95. So 95% visited fewer than 11 times. And because these are not included in this range, I could do the 0.95 minus the 0.4, and that would also give me the 0.55. So however you want to think about it. I think it's probably easier to think about adding them up, but that information exists in other places. Find the percentage of students who visited 9 or more times. And so I can use another color. Let's see, what color haven't I used yet? That's going to be 9 or more. So that's going to be this number here and this number here. I can add those two together. So that is 0.15. It's the 0.1 plus 0.05 will give me that 0.15. And what kind of data are the number of visits? In as much description as I possibly can. I know that that is quantitative. We are looking at a quantity, right? Quantitative. I know that it is measured. Let's go back to our table and see. It's discrete. I can't spell discrete, but it is discrete, right? Because you can't visit 1.5 times. You can only visit in specific intervals. So this is discrete. And let's see, is it interval or ratio? Really the question you're asking is it temperature? If it's not temperature, then it's ratio. But let's ask, is it ratio? Does 0 mean there were no visits? Yes, 0 means there are no visits. Are 10 visits more than 5 visits? Double 5 visits? Yes, we can make a ratio out of the number of visits. And so it is ratio. And that tells us the types of data it is. The final thing that we have to look at, and this one I'm gonna actually we'll lump these together because there's not a whole lot in 1.4. Although it is important stuff, I will show you what you need to look at and how to be able to process what is going on there. So 1.4, we're not going to do 1.5 or 1.6 of this chapter. We're going to stop at 1.4. 1.4 talks about how to do experimental design and then talks about ethics. So we have explanatory variables and response variables. Those are things that you might call independent variables in previous classes. These you might have called dependent variables. Dependent. And you can, again, look to the words for help in understanding what this means. The response variable is, it shows that, so let's say I want to measure how much time students spend studying and whether or not it improves their test scores. So the explanatory variable is how much time they study. That explains the response value, their test score, or I want it to explain the test score. And so that's what those two types of variables are. The different values of the explanatory variable are called treatments. And so this is the values of the explanatory value. And so that's the number of hours spent studying, or the one example that we'll use at some point during this semester is an exam score based on the number of alcoholic beverages consumed in the 8 hours prior to the exam. So in the case of looking at that, like I want to see how much do test scores go down relative to how much alcohol somebody has consumed. And we might say then that the alcohol is the treatment and the experimental unit is the test score. It's the thing that the treatment impacted. And so this is the values. Oops, I realize that you can't see half of what I'm writing here. The values of the come on, let me do it. Just make it full size here. Values of the response variable. variable. And we can set up these experiments for all sorts of stuff. It probably wouldn't be ethical to set up a drinking challenge prior to an exam, but there you can set up all sorts of different types of experiments to see whether or not one type of variable has an impact or a relationship with another. Let's not say has an impact, but there's some sort of relationship that we can see. And so that's explanatory and response variables, treatments and experimental units. And then we have lurking variables, control groups, placebos, blinding, double-blind experiment. Those are all covered very concisely in this part of the chapter. They all pretty much make sense. So go ahead and take a glance at it, take a shot at coming up with the definitions. If you are having trouble coming up with any definitions, if you go to the contents of a chapter, there's a key terms section for each chapter, and you can actually find definitions of those vocabulary words there. So that may be helpful for you if you're having trouble coming up with one on your own. That is not what I wanted to do. No idea what I just did there. Contents, back to 1.4. And then the final thing that you are going to do is you will look at these problems that they talk about, concerns about ethics, practice those, and then come back and do the ethics problem in the study guide. That one is going to, well, let's see, there's actually two of these. There's one that asks you to talk about what the explanatory and response variables are in a study, what the treatments are, what the lurking variables are, but you'll have practice with that because you will have finished reading that chapter. And then we get into ethics. We want to know what informed consent is, and then to be able to identify potential ethical issues in different studies. And again, the chapter does a really good job of giving you examples of what that looks like. So the last bit of this is pretty logical to understand. It is important to understand, although we're not going to be doing anything in this course that straddles any lines of being ethically sound or unsound. It's still important to know how ethics figures into the way that we design experiments and collect data. And so that is the entirety of the study guide. If you've got questions, reach out to me or show up at our class student hours, and I will make sure that I answer those questions for you and get you well on your way to being able to do the homework assignment. And so that is it for us for this study guide.